Okay, let's get started. So, you know, they always say sharing is caring. This is why I take my time out to share the knowledge with you. This is how I was raised in Africa, that, you know, my grandma raised me to share with the people. That's why I'm sharing the knowledge with you, because I love you so much. That's why I do all this from the bottom of my soul, the bottom of my heart. Let's get started. So now let's say here integrate. So first and foremost, what I'm going to do, take this one here and then do completing the square. Very, very crucial. So I'm going to say, take this one, let me rearrange. I'll take only this part here, x square, and then minus 2x, and then plus 3. So I'll take negative out, x squared, that's going to become positive 2x, and then let me write my 3 out. You know, 3 is going to become negative, this is going to become positive, positive, this is going to become negative. So then the next step, add the number here, take this number, anything which is in here divided by 2, and then square. So what is this number? We plug your number, which is positive 2, whichever number is here, but for this case now it's positive 2. 2 divided by 2 equal to 1, 1 squared equal to 1. So all these numbers can become 1. And then whatever you add here, you must subtract on this group. So this can become negative, okay? X squared. But this is completing the square. So we know here, let me do this. This can become x plus 1 square. All this expression here, this negative 4. So we can put it in, this can become negative and this can become positive. So I'll write this out to the positive, and then this can become negative and this can become positive. So positive 4 minus x plus 1 square. So you have already completing the square, this expression. So I'm going to have to rewrite this and say this same as, so same as, I'll just show this just in case if you forgot how to complete the square. So this expression is going to become integral, and then we have an x on top, and this can be square root 4. 4 is 2 square minus x plus 1 square dx. So now there's 2 ways you can do this question. See, but me personally, I prefer to do this question is substitution. So I'm going to say let x plus 1 u equal to x plus 1 equal to x plus 1. So this x here, u equal to x plus, this is going to become u. And then let me switch, say, okay, what about x here? Because this u is going to come here. And then du equal to dx. Dx is going to become du. But this x, okay, now let's substitute. So it's going to become integral x. What is x? X equal to u minus 1, because 1 can come here. So it's u minus 1. And then we say square root 2 square minus, this is u, because u equal to that one, u square, and then dx equal to du. So I can separate, I can say u over all this expression, then negative 1 over everything. So this time is say, simple as saying, I can just say integral of u over all of this, which is 2 square minus u square du, minus integral of 1 over all this stuff, which is u square, 2 square minus u square, square root, and then du. So I have to solve this on separate, okay? This is going to be substitution, and this is going to be sign substitution, okay? This one is easy, even this one is easy too. So what I'm going to do, I'll let, can just do, okay, let me start with this one first, and I'll count for this. Okay, let me start with this first. So I'm going to let this equal to another letter, let's say v. So let v equal to 2 square, which is like a 4, minus u square. Let's differentiate, because I know if I differentiate, I'm going to get u dv. Okay, differentiate dv equal to, this is going to give me negative 2 u du. So u du, I can divide by negative 2. So this negative 2 is going to come at the bottom, because this is going to cancel. So u du equal to dv over negative 2, and then this half here equal to v. So I can substitute back here, see? And this is going to give me integral. U du, what is the u? Negative dv over negative 2, dv over negative 2. But this negative 2 is going to go to the back, so it's 1 over 2, because negative 2 go to the back. Okay, see? Okay, u du equal to dv, just like I would say. This is u du. Now, we're left with 1 over, okay, this expression here equal to v over v. But what? Square root. Square root. See, and this is finished because then this, let me say, negative 1 over 2, I can reciprocate. So it's like integral of v negative a half dv. So that's the power rule of integration. Add by 1. When you add by 1, it's going to give you v positive a half. So I'm going to left with 1 over 2 v positive a half. But the same thing we did here, because you take negative a half plus 1, you do the same thing, negative a half plus 1 at the denominator, which is going to give us what? Positive a half. This and this cancel. So this, let me say, negative v square root, because a half is like square root, v squared. And what is our v? We bring it back. V equal to 4 minus u squared. So this, let me say, equal to negative 4 minus u squared. So 4 minus u squared. You see? But then I need to go back, because in equation they give in term of x. So what is u? U equal to x plus 1. U equal to x plus 1. So this is going to become negative square root 4 minus x plus 1 and then square. And then you can simplify further, because x plus 1 equal to okay, x plus 1 alone equal to, okay, that's right, this is, let me say, we got negative here, so we have a 4, but x plus 1, we can write a little bracket here, minus x plus 1 is like x squared plus 2x plus 1 plus 2x plus 1. If you expand that, now we can put that one inside, so we still have our negative, and then we have a root. So this is going to be 4 minus x minus 2x, so let's start today. Negative x squared. Okay, now negative 2x. 4 minus 1 equal to positive 3. Oh, so all this stuff, it gives us this expression here. Now we count for this. So I can just simply write under here and say this is going to give us negative and the root of negative x squared minus 2x plus 3. Oh, this one here. Or you can write even here aside, just in case. So all this expression here is going to give us this. So now we want to go for this one here. So I'm going to raise part an exam, make sure you show a solution. You can even say here, take integral of, so they know exactly what you did. Integral of 2 square minus u squared du, and then you do all the steps by letting v equal to that. So now we want to count for this, which is way easy. So you can just say take this one right here. So this is a sign substitution tricky, because if you have a number minus u squared is a sign substitution of the tricky substitution. Okay, now we're going to say let u equal to this number, which is 2, okay, equal to 2 sine of angle. Differentiate is going to give you du. When you differentiate, this is going to give you cos of theta d theta. Okay, so now we have all the values here. So this expression is going to become is here integral 1 over, this is 4 or 2 square, you can say, minus u. What is the u? U equal to sine theta, so it's like 4, or you can say 2 square, whatever you prefer. Or you can say this is 4, 2 square with 4. Okay, and this can give you, when you square u, 4 sine theta. Okay, and then what is that du? Du equal to 2 cos theta d theta. Okay, now we go. So this one here is going to give us 2 cos theta. Use trigonometry, because you say 4 bracket 1 minus sine square theta. Okay, this you can separate square root of 4, and this is going to give us square root of 1 minus square theta. But 1 minus sine square theta equal to cos square theta, but it has a square root. This is going to give us cos of theta, and this is going to give us 2. That's to say this all is, like I said, it's going to give you 2 cos theta. I'm just doing for, just in case, for the new people, you know, or people who just in learning process. So then this is going to be integral. So this is going to be 2 cos theta, and here is going to be the same thing, 2 cos theta, they have d theta. This and this cancel. So it's this same as say integral of d theta, which equal to theta. So all this stuff here equal to theta. But in the equation, it now gives the term of theta. Now you have to come back here and replace this theta. What is theta? Look, I have to come back here. Divide by 2, it's going to be u over 2 equal to sine theta. you have to equal to sine theta. Okay, but we want theta. So sine inverse, or you can say arc sine inverse of u over 2 equal to theta. Sine inverse or arc sine. When you say sine inverse, arc sine is the same thing. But what is that u? U equal to x plus 1. So this let me say sine inverse x plus 1 over 2 equal to theta. See? So all this stuff here equal to, instead of a theta, say sine, because theta goes sine inverse of x plus 1 over 2 equal to the theta. Or if you don't want to say sine inverse is the same as say arc sine. Same thing. So I can say, oh, so now I got it. So this expression, see, is in x. Everything in x, how they give us. So I can say minus this one here. You can say sine inverse, or you can say arc sine, whatever you prefer. Arc sine of x plus 1 over 2. And the plus of constant. So this is how the question is getting done. See? So thanks a lot for your time. It's very, very important and crucial, that you follow my website, because on my website I have my range of the products that you can purchase. And the products have got the quality material. A lot of them come from overseas, various countries, and most of them also made it local. So we can provide opportunity for the local brother and sister, so they can stand on their own 2 feet. That's because the initiative that I started to do all this inner growth and giving the knowledge back and show my talents, so that I can show the awareness, in the products that you can purchase from the website. See, meaning also is an opportunity for the other people who, can also benefit from the program. So thanks a lot for your time, and I appreciate your time, and I'll see you very soon. I allow you to do this from deep in my heart. Thanks, peace, and I'll see you soon. Peace. 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 Thanks a lot. Thanks, Melissa. My queen, you gon' wait me till Jesus come. Why when I talk, pocket full floss, money, honey, forget about Suzanne. So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer.